Hello,
Hey,
can you hear me?
yeah, I can hear you. Can you hear me?
Yes, is my voice audible?
Yes, I can hear your voice pretty well.
All right, all good. Yeah, how's your day been?
Yeah, I'm doing pretty good. How's yours?
Fantastic. Thanks for asking. But yeah,
Yeah,
let's begin.
yeah, sounds good. You can hear me correct, right? I just wanna. This is the first time using this platform, so I want to make sure that my audio is very, very clear to you.
Uh-huh. Yes, I can hear you. All good.
Okay, sounds good. So why don't we do this? Let me quickly go ahead and do an introduction, and we'll leave about 45 to 50 minutes to actually do the coding part. So in the meantime, I will just kind of to talk a little bit about the position that I work at Microsoft, and also to get a little bit of your context why you're focused on this, specific for Microsoft and what you want to get out of it. How does that sound?
Yep, all good.
Cool. So yeah, my name is Derek, and I work in the operation analytics team. So we do a lot of dashboard, dashboarding, telemetry type of work regarding the Microsoft Azure platform. And typically, stuff that we do is more infrastructure heavy. But yeah, like I've been in this position for the past few months. Actually, recently gone through a job search myself. So I think it's a really good time to kind of talk to you about what you're looking for. If there's anything that I can support on the side, we can probably leave some time at the end of this interview to kind of go over that. But yeah, if you don't mind, just kind of let me know, like what you're looking for currently. How can I support you?
Yeah, thank you. Thank you for the introduction. So, right now, I am a third. I'm a college student. I am a third year computer science major. I go to a public school in California. And tomorrow, actually, I have an intern interview coming up for Amazon. So I've practiced most of the lists on lead code. Uh, done. I mean,
Okay.
I've been. You said that this was your first time on the platform, correct?
Yes, but I've been doing like mock interview for a very long time. It just this particular platform. Yeah.
Okay, but yeah, I've been a long-term user of this platform. So whenever I have an interview coming up, just to calm the nerves and just work on skills again. That's what I do. So I guess like just just try to. I guess if there's anything, yeah, I just want you to make it as realistic as possible. That's what I would love to expect from you. And just
Of course,
uh,
of course.
and if you could let me know like some of the quote unquote red flags, or basically I'm just trying to refine my skill as an interviewer. So even if they're like tiny nitpicks, just at the end, just let me know, so I can work on even the tiniest of the details. But yeah, that's basically it from me.
And if I understand this correctly, for in this interview, is it going to be the first round phone interview, or this is an on-site interview? Because for different round, the expectation is also a little bit different depending on the question difficulty and all of that.
Um, quite honestly, I mean, I had one Amazon interview. I mean, this is for a fall intern position. I did one for a summer intern position. This was like a year ago. I mean, I
Hmm.
didn't get the job, but the question was literally a lead code easy. It was just a hash map question. But usually these intern rounds are just one or two coding questions, and they
I
just
see.
ask you some behavioral questions. So it's just one round, 1 45-minute round.
I
Um,
see. I see. Okay. Okay. Yeah. So yeah, I'm pretty familiar with the Amazon interview process. The behavior question could be like about 15, 20-ish minutes, right? And then in the next 30-ish minutes, they would need to give you a time that you're able to manage to finish within that time frame. So let's get into it. I'll provide you with the problems. And also, I want to make sure that if I give you this question and you have seen it before, I have done it, I don't want to waste your time. So that I can have a lot of questions I can take from. So just let me know. Okay.
Sorry, all good. Yep, yep.
Okay, so what programming language do you want to use?
I'll take Python 3.
Okay, Python 3, no problems. Cool. So for the intern, let's go with this one, and then again, right, if you've done it, please let me know. Ask like a different question.
Yeah, group anagrams. Yep, I've done this. You sort them in a dictionary. Yeah, I've done this.
So can you walk me through just the high level time complexity, how you want to do it?
Okay, yeah, no, I'll explain just the approach of this. So given an array of strings, group the anagrams together. You can return the answer in any order. An anagram is a
Mm-hmm.
word or a phrase by rearranging. So what we can now do is, since each anagram, a word is an anagram where the what we can do is so let me give you an example. We have
Mm-hmm.
nat and tan. So what we can do is, if I take nat and I sort its characters, right, it becomes ant. And similarly, if I take tan and I sort its character, it also becomes ant. And so since all these anagrams have the same letters with the same frequencies, after we
Correct.
sort them, they all give us the same exact thing. So we can use the sorted string, and we can have a hash map where this sorted string then becomes the key, and then within the key refers to some bunch of values. So here, nat and tan, and let's say for eat, ate, and t, it would probably be AET, and
Mm-hmm.
AET would refer to eat, ate, eat, and T. And so for this, our overall time complexity would be so if our input list is of size, so input list of um, size n, and
Let's just say the maximum, let's just say the string with the longest length will be represented as k. Yeah.
K. Okay, cool. So input size of n, and let's say, worst case, longest string of size k. So
Mm-hmm.
what we're doing here is, first of all, we're going to be iterating. So it would probably be, for word in stars, something
Mm-hmm.
like that, and then we would probably have our word map, just a dictionary right here, and then we would do our key would be something like this. We would just join sorted word, and so this operation right here
Mm-hmm.
would probably take us uh, k log k, because
Mm-hmm.
that's the and so that operation, and we would probably do like word map, key, and word map dot get, and just do that operation so we can insert it into the map,
Mm-hmm.
and this
Mm-hmm.
thing right here is O of n. So we're doing O of k log k work, O of n times. So our
Mm-hmm.
resulting time complexity should be nk log of k, and our
Okay.
space complexity should just be O of n because we're using a hash map.
Right. Right. Exactly. So typically for these problems, this is a good solution. I will go ahead and give you another question since you probably done this before, but I want to just give you maybe 5 minutes to think about, is there anything you can do to go a little bit faster than the current time complexity?
Yeah. And so where we can save time is here where we're sorting it. And so I think what we can do is, and here's my so, instead of sorting it, right, because sorting
Mm-hmm.
is taking, we're doing this additional work. Um, I think where we can cut time is because an anagram. So yeah, so what we can do is we can sort of um, instead of bucketing them, right, with this sorted key, we can bucket them, let's say some other key, let's say 101, right, and I'll explain how I came up with that. That just could be the sum of, and I think what I can then do is I can iterate over, let's say, nat, right, and I'll do that here. If I have nat, I can just do score. That just can be, the ASCII value of n. plus
Mhm.
the ASCII
Mhm.
value of A plus the ASCII value of T, and
Mhm.
have that score and assign that here, and we could do that work outside of this for loop, and pause it for each word, and that work would probably take us
Mhm.
n time,
I
and
I
then
like this. I like the direction you're going. This is great. Let me interrupt you a second. Is it going to be possibility that when you adding characters that will give you the same score? For example, let's just say that on line 31, right? I'm creating another list. I mean another line.
mhm,
Now, let's say I have a different character here. Maybe this is ASCII A, or let's just say OPQRC, like maybe something like R, and then I have it adding another ordinary of A. Again, this is just a hypothetical, right? Is it possible that these two lines will have exactly the same score? And if so,
yeah,
how are you
yeah,
going to address those issues? Yeah.
mhm. You're right. That's a possibility. Ord of T could be also equal to ord of R plus ord of A. So that's a good edge case. Um,
Yeah.
hmm. In that case, I guess. Hmm.
Basically, I think your approach is that I like the idea because what you're doing here, right, is trying to serialize in a way that we don't have to necessarily store the every single string one at a time, right? Because you want to serialize in a way that you can quickly get in the result, right? I think that direction is very well, but I just think that the approach you came up with may
Okay.
have, yeah.
Uh, I think,
Hmm.
yeah. You said the word serialized. That does ring a bell in my mind. I think what we can do is just going off of this. What I would suggest that we do, um, and what I can do is, since there are, and so my question is, would all these
Hmm.
strings just contain like English alphabet characters, or can I also have like something like that?
Yeah, this is a good question to clarify. So one of the things that you can ask at the beginning, which is I like this clever question, right? It could be just contain small case A to Z, or it could contain like A to Z or uppercase and 0 to 9, right? So
Hmm.
let's just say you can do all of this. Yeah,
Hmm.
that's a good
Okay.
that's a good clarification question. Yeah.
So we can do that. So what I'm now trying to think is, so my thought, and the reason why I asked you that was, if it, let's say, assuming that it was just A to Z, just A to Z, then we can,
Mm-hmm.
then I
Mm-hmm.
could just use some extra memory, and like,
Mm.
had like something like, since there are 26 characters, have
Mm.
some of this sort of a thing, and this like frequency list. Um,
Mm. Mm.
and then what I can do with this frequency list is that I can just combine it together. So I can just do, after. So let's just say right now, I have
Mm-hmm. Mm-hmm.
uh, something like this, and this would
Sure.
probably for A, for B, and this would be C. So this would tell me that at this position is telling me the frequency of C. Then what I
I
can
like
do
that. Okay, I like that. Yeah. Mm-hmm.
And then what I can then do is, I can, after that, and so now this is in a list. Um, what I have to do is, do something like this, or convert that into, let's say, a string, um, something like that. So that would probably give me some sort of a string key that I can then use to index. So,
Can I ask you a
if,
question?
mhm.
So what is the problems of having the array just being the key?
The array being a key. Well, this is, yes, because arrays are mutable. The keys
Okay,
shouldn't be
I like that answer.
mutable.
Okay,
And,
good answer. Mhm.
a workaround is that in Python, this is specific to Python, we can use tuples. We can use tuples.
Mm,
But
nice.
yeah, we can convert that into a string, and then we can do that. And so, doing that using so performing this beforehand, before we jump to this, before we do some work on our hash map, doing
Hmm.
this entire work for all of our words would take us, O of n time,
Hmm.
and plus O of n space, uh, O of n time, and O of n space. And so we do that for this, and then we jump into, and for our hash map, we do the same thing. again, here's oath and time, oath and space. So at
Hmm.
the end, I guess at the I think the final answer, and I'm doing this down below here on line 71. So we would have oath n plus n time, which would just boil down to oath n time, and then we would have oath n plus n space. But at the end, the final space complexity would just also be linear. Um,
Okay, I like the solution. So I will, based on what I've seen from what you typed, I will assume that you will know how to write the code. So why don't we jump into the new question?
mhm,
I got enough notes taken down, so we can move on. Good job.
mhm.
So let me paste the new question again. If you have done this, let's walk through the thought process, and then I'll give you another question, if so.
All right,
So if you
I'll
can
give.
go to line 80.
All right. Yes.
You've
So
seen this question before, right?
given the return the vertical order traversal of its nodes, and so output here should be 9, 3, 15. This is a BFS problem. Yes, I've done this.
Okay. Okay.
And
So let's move on. Yep.
yeah.
I'll give you a new problem. Um, so let me copy that and paste it at 110.
Okay. An array of currency conversions, which means one USD is equal to point. I don't know why this everything is in red. That's undendent, not this is just. I think it's yeah, it's just bugging me, but I guess I'll still read through it. Um,
Yeah, let me just get rid of maybe the rest of the task. Maybe that's why. But
let's
yeah,
just
let me just.
let's
Hmm.
just combine it together. Like everything being in a single comment block.
Here, let
There you
me. Yeah, I'll just. Okay.
go. Yep, that's fine. Yeah,
Okay.
now it's fine. That's fine. An array of which means $1 is equal to 0.77 GBP. A list of queries containing from and to. Given the above parameters, find the conversion rate that maps to the from currency to the to currency for every single query. So we have USD and uh, yen, and we have 100. So does that? So this means that one USD is equal to 100 of JPY,
Hmm.
and then one JPY equals to 20 CHN, correct?
Correct.
Okay, and then similarly, one CHN would be 200 Thai, and then we would do USD to CHN, and so I'm assuming that would, and what would happen is since we don't have a, and then we should return 1,000, and similarly for JPY to Thai, we should do that conversion, and then similarly
Sorry, I
US
think the answer should be 2,000. It's a little bit typical here.
2,000.
But yeah. Hmm.
Okay, yep. And let's just check. So for JPY, we only have one link to the CHN. So
Hmm.
but CHN then has a link to Thai. So you multiply these values, and that's how you come to 4,000. And similarly, if there doesn't exist, okay. So I think I'm trying to think of any clarifying questions about the data, but it seems kind of obvious how these conversions are taking place. Um, the first thought, this definitely looks like a graph problem to me. Um,
Hmm.
and this looks like a weighted graph problem where, so, and I'll draw up the graph for you. So we have the USD, right? And right now it has an edge to JPY. So
Hmm.
I'll just draw an edge here, JPY, and the weight of that edge is 100. And
Okay.
similarly, JPY has an edge to CHN, and the weight of that edge should be well, it's 20, and then similarly, CHN has a edge to tie, and that edge is of weight 200. And let me make sure I have this down correct. And this seems like a hmm, also I need to make sure that um, it's 100 when I go from USD to JPY, but if I go from JPY
Hmm.
to USD, it's 1/100. So I also need to so that could be a very tricky that could be one edge case. Um, so either
Right,
I
because like currency flow both ways, right? And
so.
so
Mhm.
yeah.
So I guess I can have this. It could be like a buy. So what I can do is I can have two. So we can have two sort of edges. So one edge that goes this way and one edge that goes the in the other direction, and both of those edges will have different weights. So uh, we will
Okay.
have one we can in our when we model our data we can have one edge that goes from USD to Japan has a weight of
Okay.
100, but then similarly we would have one edge that goes the other way, and that edge would have some sort of this value. And then after this, so once we have this sort of a graph constructed, um, once
Hmm.
we do these queries, so we know we need to go to from US to China, for example, then we can just do now it's the question of should we do a BFS or a DFS? Um, I'm thinking, is there an advantage of using BFS here? I guess my other question also is,
Hmm.
it could be, well, yeah, I guess another question now I think of is, let's say that, Japan also has, and, and I'll draw this
Hmm.
edge, edge. Let's say it has Indian rupees, for example, and that has some arbitrary X value, um,
Correct.
and then but there's and that also leads to China. That could also be a case. We have multiple links. We have multiple ways to get to China. um, we can either go from Japan to China or Japan to India then to China. So in that case, BFS would be a better alternative because
Mm-hmm.
if we go from USD to Japan to India then to China, well, we're wasting compute power and it's not efficient. But if we were to do it with BFS, we would just go to USD Japan and directly to China because, uh, as we know, the way BFS works, if we reach a node, we've probably taken the shortest path. So we can do this. Basically we construct. So if the problem can be broken down into two sub problems, we construct a
Hmm.
graph, construct a bidirectional weighted graph, and then perform BFS. And we do that, and that's how we can. And so here, if you look at our queries, that will be the source, and the other would be the destination, and just like do the math as we keep on doing our BFS, and see where we reach. So that's, and I think the time complexity, since we're doing BFS, and I would probably use an adjacency list of some sort. Probably would just be O of we plus e, where we is the vertices in the graph, and e are the edges in the graph, and the space complexity uh, could just be I want to say just we. I think at maximum our BFSQ, the worst case just has all the vertices in it. Um, So I think yeah. So for first space, so that would be time, and that would be that space. So yeah, so that's my my thoughts on this problem. Yeah.
Perfect. So just to make sure that this D plus E is the time complexity where you can perform one single BFS, right? Or is this because I think the question is asking you to find multiple queries, right? Not just
Mm,
like, one starting and end. Yeah. So I think what you said was correct. I like the analysis. But if you have to done, I guess there should be another, yeah,
Yes,
like
you're right.
time
You're right.
complexity on
Yeah.
top of this. Mhm.
So we could just say that would oh wait. I think yeah.
So,
So you're right.
yeah.
I missed that. So that would just be that'll just be another
Mhm.
factor. So if Q is the
Yep.
length, so we just multiply that by Q.
Yep.
Now my only question is, does the space change? I would say no. Yeah, the
Let's just
space.
say, yeah, I just say space could be the way it is for now. Yep.
Yeah, yeah.
Because you can create an adjacency list, right? And then everything that you created in that adjacency list will remain the same. So I think we're good with that. Yeah.
Okay. Yep.
Okay. Yeah, this is perfect. So I can yeah. So I took enough notes. So why don't you go ahead and starting on this and try to write a function. I will say to you for clarification, the input will be a list of list, and then for the rates and for the query will be list of string, and the output expected to be a list of floats.
Okay. So yep. Let's just do get conversions. Um, get conversions, and we take in a rates array. Um,
Mm-hmm.
um, let's just do from typing import list. So we have those type annotations. So we would have a
Okay.
list of star. Yep. And then
Okay.
our queries would, oh wait, it could be, I'll just say it's just a list. It's just a nested list for now,
Yep.
because
Yep. Yep.
then queries would also be a list of list, and then we
Mm-hmm.
take, and that's all we take, and then we return a list of integers. Good. So we have this, and now let's build an adjacency list. So the first thing, let's make it our adjacency list. I would keep this a dictionary or a hash map. And so now what I would want to do is I would want to do for rate in rates for
Mm-hmm.
rate in rates. And I guess another question. So similar to how we have here USD to Japan and 100, could there also be a case where we have let's say and we have
Mm-hmm.
the other way around? Like, is there a possibility, and that would probably be 0.01. Is there a case that something
Right.
like that?
There could be a case like that, right? But I think to what you proposed earlier, right? Because this is an undirected, bidirectional relationship. Either way, even with or without that, you still have to create it. Yeah.
Yeah,
But yes,
I
there
think.
is a possibility like that. Yeah.
Okay, I think okay because I want to take that into account. So I'll keep that on the
Mm-hmm.
back of my mind. So we have the rate.
Mm-hmm.
So we have two would probably be rate of at the first value. The from will be rate at one, and then I think
Mm-hmm.
let me just two currency, and then from currency, and then let's have a rate. And so now what we want to do is, oh, wait, currency rate. Okay, we have that. Now what we want to do is we want to do adjacency list, um, and I want to do, I want to add an edge from my two currency. What I would want to do is I would do adjacency list dot get, and now I'm getting all the things, and if there doesn't exist anything, I return
Mm-hmm.
an
Mm-hmm.
empty list. And to
Mm-hmm.
that, I would want to add an edge. And so in this edge, I will hold two informations. I would hold what's my from currency and what's the currency rate. And similarly, and
Mm-hmm.
conversely, I would want to do the other way around. I would want to do adjacency list dot get from currency, return an empty list. And to this, I add an edge to my from currency to my to currency, and this should be 1 over my currency rate. So I think this seems okay to me. Now what
Okay.
we want to do, so now we have that adjacency list built out. Let's do, so here we probably want to do for queries for query in queries, and we would in here let's just have two currency would be query of 0, and from
Mhm.
currency would be query at index position 1. Let's also have an
Mhm.
answer array. So output, I would name this output queries, and let's do
Mhm.
that. And now I want to start my BFS queue. My BFS queue would now begin at, so I would start it off from
Mhm.
2, or what I want to do is, now here's, yeah, okay. Obviously, you want to kick it off from 2 currency, so that's that it is I've added a node, um, and
Right,
I've
because that's the starting point, right? Mhm.
yes, so that's the starting point. So now I jump into
Mhm.
my BFS traversal, and so
Mhm.
while my length of my uh, queue,
Mhm.
while the length of my queue, I would just do something like queue dot. So my um, I still need to edit. I think I should probably put more information of what I'm putting in the queue. But basically,
Mhm.
what I would try to do is I would do my
Mhm.
current node, my current node. I would probably get my current rate, and I also need to keep
Mhm.
track of of like the multiplier, because this is
Mhm.
a weighted graph, and so I need to keep that in mind. So for now, I'll just do like current multiplier or something. And so I have my current node, my current rate, current multiplier. This can change, so this is just rough idea of what I want to do. So I would just do q dot
Okay.
top 0. And so now I need to change that here. So my to currency is that. Uh, and right now my multiplier should be 1. And then
Mhm.
that should be my multiplier. So I don't think that I need to yeah, I don't think I need, so all I need is this. So if I start from
Right.
USD, right? So if it was USD to USD, the answer should just be 1, right? I mean,
That's correct.
yeah, so okay, this makes sense, because if let's say if my current node is equal to my firm currency, so I've reached my node, I can just do output queries dot append. I can just do my current multiplier, and also let me just do visited nodes. Let's keep that a set, and the first one that I want to put on there is my to currency. So I've done that. So now I want to do for uh, neighbor, or for neighbors in my adjacency list, for my current node, and I think here I want to break out. Yep. So if I've not, so here it's the case, if I've reached where I want to reach, I append it and I exit
Mhm.
my BFS, and we go on to the next query. But if not, then we traverse the other neighbors. So we go for neighbors in adjacency list of our current node. We first of all, what we want to do is we want to do
Mm-hmm.
we want to do so the first thing that we get is, because we're storing our edges in a form of a tuple. um,
Mm-hmm.
so we would first of all, so our I think this should be for neighbor and multiplier. So so we would probably unpack, because we're traversing
Okay.
through. So I think Python will automatically unpack them. What we would want to do is, first of all, visited nodes um, dot add our neighbor,
Mm-hmm.
and then to our queue we add, so queue dot append. And so what we now here want to do is, first of all, we want to add the neighbor, and then we want to grab
Mm-hmm.
our current multiplier, and then
Mm-hmm.
multiply by our the neighbor's multiplier, and then
Mm-hmm.
we keep on traversing. And now, in the case from USD to Australia, so I guess this is, in this case, we have an edge that just doesn't exist.
Correct. Yeah.
I
Yeah, because like, the kind of queries that you're getting could be like, could be null as well, right? It could be it could be an edge that doesn't exist.
So in that case, I need to check that. I can probably just, I mean, a naive way is just, I can just have a flag, honestly, and I can just set found equals true, and if, I can just have if not found. I can just do output queries dot append. We just append a -1. So I think that takes care of it. And so that takes care of that. Now the things that so another question. So let's say I
Mm-hmm.
just have INR to XYZ. Uh, is there a possibility we could get this and not have anything about them in our rates array?
Correct. So yeah, the kind of queries that you're getting from, let's say, the user could be very arbitrary. They sometimes type things that is out of the search capacity within your rates. So yeah, like the both of the start and the end input could be arbitrary, right? Yeah, it could be something that doesn't exist in the graph.
All right. So I guess one way I could check that, if if to currency not in my adjacency list, or um, from currency not in adjacency list, there is no
Mm-hmm.
point in doing this.
Yep.
So we could just do output queries dot append a -1, and then, because there's no point in going to BFS, and I think we could just indent
Exactly.
it,
Exactly.
and then we could
Exactly.
just
I like
go
that because you will save a lot of search space. Yeah.
um,
Because
only
you could
hmm?
probably argue that sorry, because the type of like the query coming from user is unpredictable, so they could possibly have a lot of bad query coming in, and if you just do the SKS, get rid of that, this can save you a lot of calculation space.
Yes, yes, I agree. The only thing is, if we can, now this block of code looks really untidy. Um, but I
Hmm.
would first, but we can definitely refactor this. But in the interest of time, let's not do that. Let's just complete this algorithm, and if we get
Yep,
time, we can address that. So once we're
of
done,
course.
we do our here we do our output queries, and then we uh, jump in. I think here we can return our output queries, and let's just do a quick dry run of the code. Let's do it on top of the function here.
Hmm.
Let's just. I want to see if I can have another. Okay, it's gonna throw that error. It's fine. Um, so okay, so now we have, and let's copy. Let's just copy this example that you provided us. Uh, so and let's just also insert add this additional thing in here uh, and I also want to see I didn't address this edge case. Um, it's fine. We'll see. We'll just fix it as we drive around. Um, so right now we have our adjacency list. So this would be our
Mhm.
adjacency list, and
Mhm.
uh, so mm, okay, and so we jump in. So we hop into our rates. So we jump into our first rate. Our first rate would
Mhm.
be so it would be our two. So let's also keep track of our variables here. Our two currency is the
Mhm.
USD. Our from currency is JPY, and our currency rate right now is 100. And here we do,
Mhm.
so here we would do USD, would then become, and we add a node, so we would add uh, JPY and 100, and then we would do the converse, and we would also to
Mhm.
JPY we would add USD, and we would then add point, or I'll just do it, keep it this way. Uh, that and then we move on to our next rate. That would be JPY to CHN. So our 2 becomes JPY, this becomes a CHN, and this becomes 20. So now we come here to our JPY, we append CHN, and then we add 20.
Mhm.
And then likewise, we do the same, we add JPY, and then we do 1 over 20. Then we go on to the
Mhm.
next. So we have CHN, and then we have tie, and we have that to 200.
Mhm.
Um, and so we come to CHN, we add tie, we add 200, and then we go on to tie, and then we add CHN and 1 over 200. And then we have, yeah, I just wanted to look at this, how we would want to deal with that. So we have JPY, and then we have our USD, and then we have 1 over, let's just keep it that. And so we come here. Um, the way it would right now work is we would come here, right, and then we would just insert a duplicate node.
Mhm.
It would just be that. Now, I think this shouldn't be a problem, and the reason we can still, so the first thing we can do, we can just make this a set, basically the entire list be a set, and since we're already adding tuples, we know that they're immutable. So
Mhm.
even
Mhm.
if this is a set and we add this exact tuple, uh, given that USD Japan 100 and Japan to USD would be I think it just depends on the assumption that this would be correct. This would be the inverse of that. Um, so we can do that. So that's a quick fix. But but that would but I don't think we need to do that because if you come down to let's see here for neighbor in, oh yes, we can just add if neighbor, and this is on line 192, if neighbor not in visited nodes, then we can just add that, because now what will happen is, let's say if we were going to Japan, we discover USD. Well, we add USD, right? We then go to China, we add China, but then we again come to USD. Well, USD is right now already in our visited nodes, and so we would,
Mhm.
and then we don't need to. So basically, this if on it just boils down to the fact that on line 192, or this statement would just never give this statement would be false, so we would never go into that block. Uh, so I think
Mhm.
our algorithm just takes care of this edge case. But
Okay.
that's our adjacency list. the way it looks. And so we have that. And now let's jump into our queries. Um, so we now have USD. So queries. So our to currency right now is a USD. Our from currency is now a CHN. And so we come here. We make this our Q. Our Q right now is USD 21, and our visited is just a set that contains USD. And right now our found is false. And so we jump in here, we check that, we check for either of these cases. Well, both of them exist in our map, so not a problem. Now we jump in here, we grab our current node, and so our current node and our current multiplier should be equal to, so we pop from our queue, so this becomes 0 and 1, and our queue is now empty. And then we check if we have reached our end goal here. Current node, we want to go to China. Our current node is USD, so nope, we have not. We continue. Then we hop into the neighbors of USD. So the first neighbor is Japan, and Japan is not. So and we check that Japan is not in our visited node, so we have not visited it. So first thing we do, we add it, and then to our queue, then we add JPY. So this should be neighbor JPY and current multiplier, which is 1 times the multiplier of Japan, or the cost it takes to go from USD to Japan, which is 20. So 1 times 20 is just 20. And we do this, and then we go back up again. Now we're here. We pop our current node, 20, and so we do that, and we realize we still haven't reached our end goal yet. So then we jump to our for loop. We go check our Japan node. Well, we've already visited the US. We visited USD. It's already in our visited node. So we don't add that to the graph or to the queue. We see that, hey, we have not visited China yet, so let's add that here. Well, before we add that to our scene, and here we would add CHN and current multiplier, which is right now, well, which is 20. And the cost it takes to go from JPY to China, that should be wait. Let me make sure I have this right. Oh, I think I got this wrong in the first place. So what did I do? I think this should have been 100. I think I looked at the wrong value. So USD, we added Japan, and in that case the current multiplier was 1, and so we did 1
right.
times 100. Yeah, so that's bad on my part. I think.
So you should get 100. Yep.
Yeah. So this should have been 100. My bad. So when we add this, so right now our current multiplier is 100. Multiplier to get to China from Japan is a 20. So 100 times 20 is 2,000. We go through that, and now we come on to our next iteration. We pop China, and then we get 2,000, sorry. And then we pop this from our queue. We jump into our while loop. We do check that, hey, our current node is where we want to reach, and we have our current multiplier.
So we ended it. Yep.
So,
exactly.
Here, we just append that 2,000 here, and then we break. Then we don't need to check, and then we move on to the next query. And similarly, Japan and Thai, we have a relationship from Japan to Thai. So similarly, as I've demonstrated, we will just do a similar logic. We'll start from Japan, or actually, wait, where's our? Yeah, we'll start from Japan. Probably go to China, and from China we'll go to Thai, and so that we will get the first multiplier 20 times the second multiplier 200, multiply both of them, you get 4,000. That's what we want. And then the other case would be USD to Australian dollar, but our if statement on line 185 would run. So
right. So I think on a high level, this makes total sense. One question is that do you still need to have the flag, given that you have the edge case on 185, line 185?
Well, right now, so the reason why I say yes, and I could be wrong, there could be a possibility we could have two separate graphs, so two unjoined graphs, right? And so if we have two graphs that are separate, well, we would still have their nodes in here. Would still have their nodes in here. Let's say we also have, let's say the XYZ, right? Another graph, and ABC, another graph, and XYZ only has an edge to ABC, and it's the same in this case. We have XYZ and the same, something like that. Well, these would still be in our adjacency list, but there's no way from USD to XYZ. So if we start at USD, we traverse everything, and I think line 188 doesn't catch that case. So that's one reason why I had this if condition here. I'm trying to see. Well, the only thing, I mean, since you mentioned this, there's probably a better way we could do this, but that's my thought process as to why I had the flag.
Yeah, that makes sense. That's fine. Okay, cool. So I think in terms of time, we started around 4:16 for this particular problem. So roughly this is the end time for now. So why don't we take a step back and by the way, do you have any last minute thought you want to finish, or otherwise we can kind of start talking?
No. I mean, if this was if we had a time, I would definitely refactor this in these indented blocks. It just kind of looks.
So why don't you walk through that? I mean, in a real interview, this is probably it. But seems like this is a mock interview. Go ahead, please. I kind of want to see like how you would have refactored this.
So I think my only the only thing is how would I like unindent, like the first would be bring this one level out. One level out. So this is I think this logic would just stay as it is. I don't think there's much that I can do to change this logic. What I can, I mean, the only way, and I think this would this would probably waste computation power, but just for the sake of like making the code look good, or not found, and then I can just cut this and paste it outside here. I think here, and we get rid of that indent, so kind of makes it cleaner to look at. But
okay.
Oh wait, no. Ooh. No, wait a second. Let me see. If current node for neighbor in current. No, this would actually.
Should you do this check like on line 201 before or after you execute the BFS?
I think we should not. Yeah, you're right. This check should be here, but then we should get rid of this and do it here if not found, because then we could potentially get a key error. So there's a possibility. If not found, we can just do dot append -1. My only thing is, well, both of these if blocks are achieving the same purpose, right? But it's like, and so what I'm trying to do is like, how can I combine these together? But it just so happens that but then if we append, we shouldn't be running this. So I think there's a
I think the way it makes sense because these two are checking on different things. One ADA is more checking whether the starting point and the end point is in the graph, and then the if not found at the end is more about like if, can even if you those things exist in the graph, but can I actually have an edge to connecting the two nodes, right? So I think having that there is okay. Yeah.
But then we just come back, right? Even if we check it, we would still jump into this while loop. So, and this just brings me back to where we started, where I had this under an else. Uh, so we're back to where we started
Oh
almost.
yeah. Yeah, you can probably yeah, that's you can yeah, you can probably break it there, just
Uh,
to so you don't have to execute on the while loop. Yeah, because
mm,
if
uh,
not, if one of the things is not in the graph, so then you shouldn't execute that. Yeah.
I think just to make it, I can just make this its own function. I mean,
Mhm.
that's
Yep.
a bit of refactoring that I can do, just to
Yep.
reduce the length of this get conversion function. So that's just stylistic at that point. Doesn't really have much impact on the performance of the code, but
Yep.
but yeah.
Okay.
Uh,
Cool. So I think it's fair for us to take a step back and yeah. So good job first of all. That was pretty good. I wanted to kind of first talk about your personal feel. Like just say this is your Amazon interview. You got this
mhm.
question. This is your performance. Why don't you do a self evaluation and then I could give you some of my perspective at
Okay.
the end.
I think from if I were to judge myself on problem solving, technical skills, and communication and verification on those four skills, I think I did the problem solving part really good. I think I explained the problem. I told you how we could get that data, how we could modify, build a graph, and then perform BFS and why BFS and not DFS specifically and like on a higher level. So I think we did that in this in like
Mm-hmm.
just comments. So I think I did good on problem solving. Technical skills,
Mm-hmm. Mm-hmm.
just the coding part. Well, I coded the question out, and I think I could have been faster. It's just that as I'm trying to explain, I'm trying to like going slow. So it's just like a very like thin balance that I must be writing fast, but at the same time I should be explaining to you the things that I'm doing. So, but overall, I think I
Right.
also did good on that. Communication, I think I was making sure that every single line I write, I just let you know what's going through my mind. So I think did good on that,
Mm-hmm.
and I think I also did a dry run of the code, so I verified to you that hey, look, my algorithm does run. Um, so I think keeping those things in mind, I mean, given that I've done interviews and mock interviews, I think that I passed the interview. So that's my conclusion. Um,
Yes,
yeah.
I think that's very accurate assessment. So let me go ahead and copy my notes that I taken over the interview. So the whole point of this reflection here is to see, if there's anything that we can do better. I think
Yes.
for depending on you said this is just for an internship, right?
Yes.
And if this is just a low for internship, this is definitely either a higher to strong higher performances. So let me break it down to you on line 213. So
Yeah.
I'm
I'm,
going to
I'm
paste
looking.
out all of the notes down here. So yeah, so the four axis, yeah, like I'm going through is very similar to you mentioned communication. I also care about problem solving. I do care about trade-off analysis and also like coding and testing. So different company using different metric, but they're on a high level very much the same. So let's start with the communication. I see you're very experienced in terms of how you communicate. Like you are drawing things out and you're going through very much step by step. I like that very thorough, like, communication. I really like that. So I think one of the things I want to add into is that some clarification on the input and output is important. I don't think you proactively did that, but then doing when you are starting, going into the problems and they realize, oh, right here, am I expecting
Mhm.
this to be, could be edge cases. What is exactly the input type, right? Because at the time when you try to do list of string, but then you realize, oh, there's a list of string and an integer there, right? So in Python, the type could be different in the array. So those are things that I will personally probably clarify a little bit more, right? So there's another thing if you look at line 206, right? this is -1, but it should be -1.0, right? Just if you want to keep that consistency of having a float type, right? So again, right, clarifying on the input output type could help you to resolve some of the issue like that. And when you go to 218, so yeah, some of the things I want to kind of ask you is that in order to save you time during an interview, right? This might be a case for company like Amazon or like Facebook. So Amazon is known for giving you a behavior question at the beginning, right? And then leave you about like 30 to 20 to 30 minutes at the end, right? So sometimes you may or may not have the luxury to talk a lot, right? So a lot of times that you probably want to ask yourself, like, can we cut down sound like talking, right? So this way you have more time to actually finish the problems, more time to demonstrate your coding ability. So you can probably situationally asking the interviewer, be like, hey, do you want me to run through an example, or do you think, I think BFS, DFS both make sense here. Doing this, like, what do you think, right? So basically picking up their mind to see where they want to direct the interview. That way you can use that to your advantage by saving time, right? So if your interviewer don't want to explain too much, they already understand everything. Yeah, you can save that time, and you can, use that time. Maybe they can give you another problem. So does that make sense?
Yep.
But yeah, I think what you did was perfect. Like, just adding that situation things, letting your interviewer decide, so that way they can get the most out of you. So that you have more time to shine and showcase more things that you have. So when it comes to problem solving, I think this is the strongest suit. You're really fast, and then you're really to the point. So basically you say, when I give you the problems, the first problem I gave it to you, we can do sorting here. And then when I give you a little bit hints on the serialization, you're able to come up with the tuple solution, right? Or the serialization solution. And then you are very strong on data structure. You know that hash map, the key needs to be immutable, right? The value could be anything. But I was trying to trick you a little bit there, but you did perfectly fine. So your data structure is really good. In terms of think about the algorithm, you also come up with this graph problems algorithm very quickly, right? So you break it down into 2 steps. First, let's make the graph. Second, let's do a traversal. And within the traversal, I really, really like your trade-off analysis. You mentioned I should do DFS or BFS, right? So you started asking yourself that question. So I will say that one thing I will add on to that is that when you are talking about BFS and DFS, right? BFS will be a shortest path. In this case, you gave me an example, but there also could be cases where we have a lot of value on a horizontal level. So one thing you probably should mention is that either BFS or DFS, worst case scenario, right? If you don't know the structure of the graph, could end up becomes V plus E, right? Like in that case, you would just basically iterate through all of them, right? And then there's also another factor in this specific question is that because you potentially have a lot of division going here. So if you think about this way, right? Like you have USD to let's say Chinese, right? Right here is 100, right? And if you do the other way around, so then you're going to get a reciprocal value of 1 divided by 100, right? You mentioned that as well. But if you imagine that if you starting off this path and start doing division, 1 divided by 100, then you divide by another 100, then you divide by another 200. You see I'm going here, right? You potentially going to lose a lot of float accuracy. The more node you traverse, right? The more accuracy you may lose in that process. So in that case, you should probably go with the one that has a shorter path. Does that make sense to you? So that's why BFS is more preferred. It could be another reason, just right there, right?
Yep.
Am I make sense? Yeah.
Yeah. No, I understand. Yeah. So BFS could be explained. Yep. I think I did it. What was your point? If you could just re-clarify just on that part.
Right. So for example, you have 2 paths, right? One is to let's just say you have 2 ways to access this USD, right? You gave an example here, like something like this, right? You have another path down here. It could be a tie, right? Yeah. And then what if you have 10 different neighbors right here, right? And then eventually you move back to USD. And then the question is should I use the BFS or DFS? In this case, the shorter path it is, the more accurate your float will be, right? So that you can avoid doing a lot of those divisions. Does that make sense? So that's why having a shortest path can avoid you from doing all of those divisions, right? So I think just a smart add up onto just for this problem specifically, right? But I think I like your analysis, right? DFS or DFS. In this question, you can do either way, right? They will both get you the answer. So I like that. Let's see. Adjacency list. Oh, by the way, there's one thing I think that I want to mention is when you are using a queue, I believe in Python, the queue you're using currently, I see is a list. What is the time complexity on line
Yeah,
193?
yeah, you're right. There is a DQ. So there is a data structure that would like just do we can just do a pop left. Um, I think this
Okay,
might
okay.
we can do that. You're right. You're right. Yeah, we can use a
Yeah,
DQ
I
here.
think I think the just have the array. If you constantly deleting things from the front, it actually might cause you linear time complexity. Yeah, I'm not really familiar with Python, but that's something I heard, right? So yeah, if you have a different data structure like a DQ, which
Mhm.
implemented using I guess a linked list, that might be a little bit better. Yeah.
Okay. Also,
Okay.
sorry to interrupt. Could we just? I actually have an interview, so if you could just go through like really fast, that'd be really good.
Okay,
Yeah.
yeah. So I think basically the rest of it, I will go ahead and write it in notes, and then I'll post it on the platform. But yeah, those are the things that I think on top of my head right now. There's a few more. I'll write in the community in the notes later, so you can go through them. I also suggest you something when I do that. Okay.
All right. But yeah, thank you so much. Also, I hope. So you said this was your first time on the platform.
Yeah, I
Yeah.
haven't used this platform at all. So
And this is funny. Well, because I'm actually an intern at interviewing.io, so I actually work for the company.
that's great. That's great. Yeah, you guys are
It
doing amazing products. So, yeah.
Yes, thank you so much. I actually actually they had their intern position through their jobs board. I applied and they gave me a job. I'm like, cool. But yeah, but thank you so much for your time. I unfortunately got to run, but thank you so much. This was
Yeah.
a great lesson. This helped me a
Hey,
lot.
you did very good. You worked everything about this process. You did really good. If this is an intern for Amazon, I think you can get this job in a heartbeat. So good job on that. Continue what you're doing and good luck. Best of luck on that. Yeah.
All right, thank you so much. All right, see you later. Bye.
All right. Talk to you later. Mhm.